show the portion of the Tidbit project that me and my teammate Alberto Mizrahi is working on. So I'm in charge of the backend API currently, most of the backend API. Currently, we have the user routes and the authentication routes implemented, and I'm going to show that and the code for that and everything working along with the database, the server, and all of that. And I'm also going to be demonstrating the code that we have, as well as the GitHub repo where this code is hosted. And I'm also going to be showcasing the documents, the Agile and Scrum documents that we've had following through this class. So if you hit our index route, um, it comes up with a welcome message, just letting you know that, hey, this server is Tidbit's backend API server. So now I'm going to demonstrate the features of this server. So currently, you can send a request through this route to create a user through the by posting through the to the slash user route. So if I send a JSON payload of a username, password, first name, and last name, it'll say that I successfully created a user. And if I try to send again the same user, it will detect that it's a violation because I'm creating another user with the same username. Hence why the system can detect this. So if I do a select star from the user table, it shows here that I freshly created a user. So let's say I made a typo and I hate the username, so I'm going to change the username. I can do a post request to the um, slash user slash ID, some ID, and the ID is provided in the database. And I can change any of these four attributes that I used to create a user. In this case, I'm going to use it to change the username because the username is not appropriate. I'm going to change it to aparagus. It's going to come up with the fact that I have invalid permissions to update the user. So what I'm going to do is I'm going to authenticate myself by authenticating myself in this route, the slash authentication route. I'm going to make a post request. I'm going to make a raw request, of course, in JSON. And my request will have a username attribute and a password attribute. Currently, my username is Alistair. So I'm going to authenticate myself using that. It successfully authenticated me, and it gives me this JSON web token I can then use on the authorization header to authenticate myself. So authorization, dir, and then that. So I'm going to send, so given that authorization header, and I can now send an update to update myself. So now it shows that I successfully updated the user. So if I show myself on the database, you can see that our username was successfully changed. What else? I can publicly access user information. So I can go make a get request to slash user slash ID, and it shows that I found information about me. Now, if I pass in an authorization header, and I can just demonstrate that right now, you can see that it reveals us more information. In this case, history, which is the history of websites a user has accessed. And that is because I have an authorization token that I passed in, which basically means this is the private user viewing his own information. Last but not least, I can actually send a delete request to a slash user slash some user's IDs route. And if I do that, it successfully deletes the user. So now if we do a query on the database, we shouldn't have any user. And lo and behold, 0 rows, that means we successfully deleted our user. So let me go through the code, at least the backend's code. So we implemented a lot of best practices in this project, mostly because it's a research project and we want everything to be stable. So most of the routing information is on server.py, which is on the top level namespace. Top level namespace right here, server.py. Everything, by the way, is made with the newest version of Python, Python 3.6, because we're using what's called asynchronous generators, which is basically a lazy way to load asynchronous data. So yeah, so we have our environment variables defined here for the database Docker container. All of the environment variables are specified here. For the backend, all of the environment variables are specified here. And these environment variables are set so that the Docker configuration reads them during runtime and loads those environment variables into the server. The actual configuration I have right now is on backend.env and relationaldb.env. We have a nice set of documentation in our README. Of course, we have unit tests mocking stuff out, and I can demonstrate that this unit test runs if I do a Python run. Let me just do a quick Python run. Actually, let's forget about this. I'm just going to do a Python test run, Python m unit test, d test db user repository underscore test.py. So it shows that it ran 9 unit tests and test cases, and they were all okay. So in the application, we of course have 3 controllers, 1 controller per main route. So in our project, we have the /user, /authenticate, and /summary route. We haven't finished working on the /summary route because that's where most of our natural language processing and machine learning algorithms will go. And currently that is Alberto's portion, but he will be demonstrating those algorithms on another portion of this video. We of course have some utils. In this case, just a module that creates and gets the contents of a JSON1 token. And finally, we have a lot of database modules. We have a document repository, history repository, and user repository. And basically, these are classes that represent what the separate tables of a database, of our database, is like. We also have a utils, which handles a lot of the low-level database administration needed by those repositories, repository modules. We have a startup, which listens to the server, and when the server starts up, so then we can start up the server. When we start up the server, we can do some configuration to prepping up our backend. And finally, we have a cleanup, so we can cleanly clean up our servers whenever it shuts down, so we can clean it of resources. My portion is in Tidbit app, github.com/tidbit app/backend. And of course, you can see our nice documentation, our relational database schema, our API routes, and the technologies that we have used. And Dr. Sajadi has shared with us our automated document summarization documents where we put all of our Agile/Scrum documentation. So as you can see, Sprint 1, Sprint 2, and Sprint 3's documentation is right here. For every sprint, we have our review meeting minutes, our retrospective meeting minutes, our planning meeting minutes, and our daily Scrum meeting minutes. So if I show you our latest one, the latest past sprint, you can see that we have our daily Scrum meeting minutes, our sprint review meeting minutes, and our retrospective meeting minutes, and our planning meeting minutes. I'm currently in is a very bad internet. But yeah, so that's where our documentation lies. Basically, for every sprint, we have our review meeting minutes, retrospective meeting minutes, planning meeting minutes, and Scrum meeting minutes. And on the other end, Alberto will be showcasing his code, the Mingle user stories, and other possibilities that I have not covered. So that basically is what my side of the project is, and thank you for watching.
So given that our project is heavily based on machine learning and natural language processing, our team decided to dedicate part of our sprints to research these subjects and get better acquainted with the theory behind them. In order to achieve this, we decided to go through part of Andrew Ng's lectures from his Introduction to Machine Learning course in Stanford University. Here shown are some of the lecture notes that we took, and the rest of the lecture notes can be found in the Google Drives folder. Now, these lecture notes were incredibly interesting and they covered a wide range of subjects. As a matter of fact, one of the subjects that we covered, we decided to implement ourselves, and we will show this right now. The problem that we implemented, or the solution to the problem that we implemented, is the cross-validation algorithms. Now, what is cross-validation? Given a machine learning problem and some data, you want to choose the algorithm or the learning model that learns from the data the best possible. Now, how do you know which algorithm learns from the data correctly or as efficiently as possible? And that's exactly where cross validation comes in. We implemented three different cross validation algorithms, and they all let you choose which learning model is the best for your specific problem. We also implemented a testing program that will test the cross validation algorithms by creating some dummy data and some dummy learning models, and we'll show this right now. In in this instance of our test application, we create various models, and the model with the highest accuracy that we create is this one. It's given by 0.98 percentage of accuracy. We can see that all three cross-validation algorithms actually choose the most accurate model, which means that the algorithms are working as expected. And we will be using this cross-validation algorithms for our machine learning for our machine learning solutions. Another important subject that we covered and another important algorithm that we implemented was a summarization algorithm. Now, we hope to offer our users many different summarization algorithms that they can use depending on which one they think works best. This is one of the algorithms that we'll be using, and it's a frequency summarization. The way it works is that it uses natural language processing to break an article into sentences, and then it ranks each of those sentences in order of importance. And then it will output, say, the 3 or the 5 most important sentences of the article in the order in which they appear. Now, how do you calculate the importance of these sentences? Now, the importance of each sentence depends on the words that it contains and how frequently those words appear throughout the article. We have an example right here. We have this article from Bloomberg, and we can run the algorithm, and we can see that it outputs the 3 most important sentences of the article. Now, in this case, it does a very good job in capturing the essence of what the article is saying. And for most of the articles that we tested, it did a good job. But for some of the articles, it did not work as good as we expected. And so that's why we will try to offer very many different algorithms so that the user can choose from the one he likes the best. Finally, we will cover the Mingle dashboard of our team. Here's the Mingle dashboard of our team. You can also see the release tree, and here's also the sprint planning. Our team has tried to be as responsible as possible to keep Mingle up to date, and we've successfully done that so far. You can see here the sprint planning dashboard, and you can also see here the sprint board for sprint number 4, which is the one we're currently in. We hope to continue using Mingle to keep our team organized, responsible, and up to date so that we can successfully complete our project and have a polished product that works as expected.